Hello everyone. Today we will be discussing the topic flow through pipes in series or flow through compound pipes. This is coming under module 3, the last portion of module 3. So mainly we'll look into two main portions. One is pipes in series, and in another session I will be discussing the topic pipes in parallel. So let's start with the series connection, that is compounding of pipes or flow through compound pipes. So first of all, let us discuss what is compound pipes. So it is defined as the pipes of different length and different diameters connected end to end in series to form a pipeline. To better understand this, let us look at a figure. So in this figure, there are two reservoirs A and B. So these two reservoirs A and B are connected by not by a single pipeline, or rather by a set of three pipes which are differing in length as well as in diameters. So wherever we do not have a single pipeline to connect these two reservoirs, we will go for compounding of pipes. That is, compounding means they are connected in series one after the other. And all these pipelines will have different length. Here it is L1, L2 and L3, and different diameters D1, D2 and D3. And also the coefficient of friction for each pipe will also be different. That is small f1, f2 and f3. And H is the difference of water level, or the level difference between the two reservoirs A and B. Now, the important thing to note in the compounding of pipes or pipes in series is that the discharge through each pipe will be the same. So we can write Q is equal to A1 V1, that is discharge through the first pipe, which is equal to A2 V2, discharge through the second pipe, which is equal to A3 V3, which is the discharge through the third pipe if there are three pipes. It can be two or more pipes. So and another important thing to note is that the loss of head due to friction will be the sum of all these happening in these three pipes. So important thing to note is that the discharge will be the same in each pipe, and the head loss due to friction will add up in the case of series connection or compounding of pipes. So if minor losses are neglected, that is, we have mainly two types of losses, as you know, in pipe flow. That is, one is the major loss, that is the loss due to friction, of which equation is 4FL V square by 2GD, that is our Darcy's Weisbach equation. And that is the only major loss, that is head loss due to friction. All others are listed as minor losses, that is, it can be loss due to any bend in the pipe or any sudden expansion or contraction, and all others comes under minor losses. So minor losses are beyond our scope of study. So in our syllabus we will limit ourselves to the major losses, that is, we will consider only the head loss due to friction. So you will find that it is written here minor losses are neglected, and therefore if the minor losses are neglected, the head loss will be the sum of all these, that is 4F1 L1 V1 square by 2 GD1 plus 4F2 L2 V2 square by 2 GD2 and 4F F3 L3 V3 square by 2 GD3. This is HF1, this is HF2, this is HF3 respectively for pipe 1, 2, 3. Now we know that the coefficient of friction is same for all pipes, so F1, F2, F3 is equal to F. So substituting that and simplifying the equations and then taking 4F by 2G as common, we can write the equation as H is equal to 4F by 2G into, inside the bracket, L1 V1 square by D1 plus L2 V2 square by D2 plus L3 V3 square by D3. Now we will see a problem on compound pipes. Three pipes 400 mm, 200 mm and 300 mm diameters have length 400 meter, 200 meter, and 300 meter respectively. They are connected in series to make a compound pipe. The ends of this compound pipe are connected with two tanks whose difference of water levels is 16 meter. If the coefficient of friction for these pipes is same and is equal to 0.005, determine the discharge through the compound pipe, neglecting first the minor losses and then including them. Even though the problem is to involves two cases, neglecting minor loss and considering minor loss, we will limit ourselves to the solution neglecting minor loss. So first of all, we will write the given things, that is head loss. Difference in water levels between say tank A and B is given as 16 meters, so H is equal to 16 meter, and L1, L2, L3 is given of pipe 1, 2, 3, and D1, D2, D3 is also given, and we know that coefficient of friction is same for all three pipes, so F1, F2, F3 is equal to 0.005. So we have already said that for compound pipes or pipes in series, the discharge will be the same for all three pipes, or in other words we can write A1 V1 is equal to A2 V2, which is equal to A3 V3. So if V1 V2 and V3 are the velocities in first, second and third pipe, we can write Q is A1 V1, which is equal to A2 V2, which is equal to A3 V3. So to continue with the problem, we must convert these V2 and V3 in terms, we must write V2 and V3 in terms of V1, so that everything will be in the same parameter. So considering first two equations, A1 V1 is equal to A2 V2, from that I can write V2 is equal to A1 V1 by A2. So area, we know that it is a circular pipe, so the area will be pi by 4 d1 square for A1, and A2 area will be pi by 4 d2 square. We already know the value of d1 and d2, so substituting and simplifying it, we can write V2 is equal to 4V1. Similarly, considering first and third equation, A1 V1 is equal to A3 V3, because we are trying here to write V3 also in terms of V1. So V3 is equal to A1 V1 by A3. Substituting the value and simplifying, we will get V3 is equal to 1.77 V1. Now we are neglecting the minor losses, so the only loss happening is head loss due to friction, and for a series pipe we already know that head loss due to friction will sum up, so we can write H is equal to HF1 plus HF2 plus HF3. HF1 is the head loss due to friction, and from Darcy's Weisbach equation we already know that HF is equal to, that is head loss due to friction, is equal to 4FL square by 2GD. So for first pipe, 4F1 L1 V1 square by 2GD1. Similarly writing for the other two pipe, and substituting the values, capital H is 16 meters, which is already given in the problem. 4 into F1, F2, F3 are all same, so it is 0.005. L1 is 400. V1 we don't know, we have to find out V1, so V1 square by D is, first diameter of the first pipe is 0.4 meters, 2 into 9.81. Similarly substituting the values for the other two pipes also, wherein the only difference is V2 we will substitute as 4V1 square, which we just obtained, and V3 we will substitute as 1.77 V1 square. So simplifying and substituting, simplifying these equations, we will finally get the value of V1 as 0.882 meter per second. So we are asked to find out the discharge. So once we find the velocity V1, we can easily find discharge. Discharge is equal to Q is equal to A1 V1, which is equal to pi by 4 0.4 square into 0.882, which is equal to 0.1108 meter cube per second. So this is the final answer. Now let us look at what is an equivalent pipe. So it is defined as the pipe of uniform diameter having loss of head and discharge equal to the loss of head and discharge of a compound pipe consisting of several pipes of different lengths and diameters. That is, in earlier session we have just looked at what is a series connection or what is compounding of pipes. So wherein compounding a pipe means two reservoirs which are at different lengths are joined together by two or more different pipes which are having different length or diameters, etc. So equivalent pipe means if we can replace these two or more different pipelines by a single pipeline, so that the condition is it should have the loss of head as the same, and also discharge also should be equal to that of the compound pipe. Okay, hope you have understood it. So uniform diameter of the equivalent pipe is called equivalent size of the pipe, and the length of equivalent pipe is equal to sum of the length of the compound pipe consisting of different pipes. So you should understand that equivalent pipe is nothing but we are replacing the two or three compound pipes which we have fitted in series connection by a single pipeline, such that the loss of head and the discharge will remain equal. So such a pipe having uniform diameter is known as equivalent pipe, or it is called equivalent size of the pipe. So to better understand this topic, let us look into this in detail. So let L1 be the length of the pipe 1 and D1 be the diameter of pipe 1. Similarly, L2 length of pipe 2, L3 length of pipe 3, and D2 and D3 are diameters of pipe 2 and 3, and H is the total head loss, and L is the length of equivalent pipe. Equivalent pipe, as you know, the pipe that we are going to replace and newly fit, and let D be the diameter of the equivalent pipe. So one condition of equivalent pipe is that the length should be the sum of the length of each of these compounded pipes. Now the total head loss in compound pipe, like neglecting the minor losses, will be the sum of all these, that is H will be HF1 plus HF2 plus HF3, where HF is the head loss due to friction, 4FL V square by 2GD. So we already know that the frictional coefficient of friction, that is small f1, will be the same for all the pipes. So f1 is equal to f2 is equal to f3, that we are calling as small f, and q is equal to a1 v1, a2 v2, a3 v3. That is, this is the condition for series connection of the pipe. So substituting, a1 is pi by 4 d1 square into v1. Similarly for pipe 2 and pipe 3, and writing it in terms of v1 is equal to 4q by pi d1 square. Hope you have understood that how to write this. So that we will substitute this v1, v2, v3, etc. in this equation. So after substituting, we will get the equation as H is equal to 4FL1, substituting V1 as V1 square as 4Q by pi D1 the whole square, etc. For similarly for V2 and V3, and then simplifying and writing, we will get the equation 4 into 16FQ square by pi square by into 2G, and inside the bracket we will be only left with L1 by D1 raised to 5, L2 by D2 raised to 5, L3 by D3 raised to 5. So I am calling it this as equation number 1. Now for the equivalent pipe, head loss due to friction is, we already know, 4FL V square by 2GD. This is our equation as per Darcy's Weisbach equation. And similarly, what we have done in this case, we are adopting the same method here. So to replace this V, we will have Q is equal to AV. From that, V is equal to Q by A, which is equal to Q by pi by 4 D square. So rewriting V is equal to 4Q by pi D square. And this is for the equivalent pipe. So substituting this V here, we will get H is equal to 4FL, and for V we write 4Q by pi D square the whole square by 2GD, and finally simplifying we will get this equation. I'm calling it this as equation number 2. So from the definition, coming back to the definition, we know that an equivalent pipe is a pipe which should have the same head loss as that of the compound pipe. So as per our definition, these equation number 1 and 2 should be equal. This is for the compounded pipe, this is for the equivalent pipe. So the head loss due to head loss in the compound pipe should be equal to head loss in the equivalent pipe. So we can equate equation number 1 and equation 2. So equating these two, we can write it like this. And finally, we have our equation for um, equivalent pipe, L by d raised to 5. This is our final equation. L by d raised to 5 should be equal to L1 by d1 raised to 5 plus L2 by d2 raised to 5 plus L3 by d3 raised to 5. Now this is the equation for equivalent pipe, where L is the length of the equivalent pipe and d is the diameter of the equivalent pipe. L1, L2, L3, D1, D2, D3 are the length and diameters of the compound pipes, that is pipe 1, pipe 2 and pipe 3. Now this equation is also known by another name. So this equation is also known as Dupuit's equation. In this equation, you should also note that L is equal to L1 plus L2 plus L3 and D1, D2, D3 are known. So easily, once L1, L and D1 etc. are known, you can easily find the value of D. Now let us look at a simple numerical problem on equivalent pipes. So three pipe of length 800 meter, 500 meter and 400 meter and diameters 500 mm, 400 mm and 300 mm respectively are connected in series. These pipe are to be replaced by a single pipe of length 1700 meter. Find the diameter of the single pipe. So this is an equivalent pipe problem. So as mentioned earlier, it is a very simple problem wherein you are already given the value of L1, L2, L3 and similarly D1, D2 and D3, and also the length of the pipe. These pipes are to be replaced by a single pipe of length 1700. So capital L is also given. You are asked to find out the diameter of the pipe. So first we will write the given things which I have already mentioned, and we have to find out this D. So writing the Dupuit's equation, we have L by d raised to 5 is equal to L1 by d1 raised to 5 plus L2 by d2 raised to 5 plus L3 by d3 raised to 5. So everything is given except D. You have to find D. Substituting the value, you will get D as 371.8 mm. So hope you have understood the concept of compounding of pipe, or which is also known as series pipes in series or flow through pipe in series. And also another important topic that we have discussed in this video is equivalent pipe. Hope you have understood both of these.